I know what you're thinking. Old Tony, didn't you already build a stand for your bike? Well, yes and no. I did build a lift stand, but not the one I really wanted. I started with the intention of building a scissor lift, but being totally honest with you here, these things are a lot of work. A lot of work. Especially if you stop to consider that you can buy one brand new for about $100. Would a store-bought one be as cool or as sturdy as the one I'm about to build? But the new year is upon us, and I made a resolution to build a scissor action mechanism. Today, I plan to see that through. I was undecided between a scissor lift for the bike or an extending boxing glove. I debated it for a few days. I would get a ton of use out of either one. So I flipped a coin, and here we are. Scissor lift for the bike and or anything else I'm too lazy to bend over for. You've seen me prep most of the material, and now comes the hard part, the part I've been dreading, the actual scissor links themselves. On top of these being a lot of work in and of themselves, in keeping with me being my own worst enemy, they're also stainless steel. Stainless steel, my old arch nemesis. I hate working with this stuff. I mean, these days we're civil, we'll say hi if we bump into each other on the street, but there's still bad blood. Unless you're very careful with your feeds and speeds, stainless will dull your saws, burn up your drills, destroy your countersinks, ruin your marriage, make your kids cry, and probably snap every tap that you throw at it. Mostly because you shouldn't be throwing taps, but even if you don't, it'll break them. With that in mind, I've got 8 links to make. Each one of these will need 3 holes. In fact, each will need to be spot and pilot drilled, then drilled to reaming size, then reamed. Some of them even need counter bores, and they'll all need deburring, of course. I'm not very good at math, but that's got to be a heck of a lot of operations, with plenty of chances to get my new year off to a bad start. So instead, I just made one. And I used my 3D photocopier to make the rest. Unfortunately, in my haste, I neglected to round the ends. The ends of these links don't technically need to be rounded, but I think they'll look a lot better. Had I done that to the first link before copying them, I'd be finished. But now I'm going to have to go back and round each one of these one at a time. What you're about to see here is not exactly the right way to do this. Nor is it the wrong way, but it is the lazy way. Far be it from me to not stop and take a moment to pass along some bad practices. Technically, I could belt grind the radius on here. That'd be pretty fast and kind of lazy, but that would get expensive. This is 3/8 inch, 3/16 stainless. I'd probably go through $150 in grinder belts to do all these rounds. The respectable way to round these would be to take the 3-jaw off of the rotary table and work directly on the table itself. Since, there's really no easy way to hold flat bar stock in a 3-jaw chuck. But if you did that, worked directly on the rotary table itself, you would need a little jig to keep the links up off the table, and a whole bucket load of clamping to keep both the fixture plate down on the rotary table and to keep your work on it. By the time I would have done all that, well, I just made this puck for the 3-jaw chuck. This just has a small step on it, a tapped center hole to allow me to clamp this down, and there's 2 pins on either side just to keep anything from spinning and cutting me in half. If I were making any more of these, 9 instead of 8, I might have dug a little harder for a shorter bolt. Give me a minute to find the chuck key and just cinch this. Not terrible. I've got a little bit of a scallop on one side. At first I thought that was me going past 180 degrees as I swung the rotary table around. But now it looks like that arc, that cut isn't centered on that hole. Or rather, it's centered on the hole, or close enough. That hole just wasn't perfectly on the center of this link. So here the cut feathers out. That's what I was expecting all the way around. And here I've got a little bit of a scallop. The one word that doesn't jump to mind when I look at these? Consist. Some of them are full rounds. Some of them still have some flats on the end. More than likely some sloppiness on my part when I was working up against the vice stop. Inconsistent stock. My jig on the rotary table could have been tighter. But again, for what I'm doing, doesn't really matter. I'm going to knock some of the sharps off of here on the belt grinder, and I can start putting these together. Some of you may have noticed this already, but there are 2 styles of links in this build. 4 with counter bores and 4 without. The counterbore ones go on the outside and the straight bore go on the inside. Otherwise, they're all exactly the same. In fact, the counterbore isn't even strictly necessary. It's an attempt to make the connections as low profile as possible. So not a lot of the cross pins come through one side. But we'll see how that goes. I may have just made a lot of extra work for myself for naught. I'm going to put these aside for now. I'm going to start by assembling the internal links first, for no particular reason other than it would be physically impossible to start with the external ones. I've got some spacers here. One is 6 1/8 and the other one is 8/19. Those are just to help keep everything evenly spaced and hopefully square during welding. I should have cleaned the inside of these links before assembling them. They're not too bad, but the welds are pulling up a lot of dirt. The two donut-shaped pieces you saw me fighting with on the lathe are just simply spacers. Anyway, these are welded. All the welds are on the inside. This is probably overkill. A cleaner way to do this could have been with snap rings or circlips. I think those would have worked anyway. You would just be doing more machining instead of any welding. Next up, I think I can start putting together the external links. I'm going to use some sleeved bushings for all the joints. These are sometimes called lined bearings. In an application like this, these should be pretty good. These are for high loads and low speeds. These have a porous bronze matrix, like a sintered muffler, bonded to a steel backer. And that matrix is full of special sauce, lead and plastics, Teflon, that sort of thing. These are used a lot in automotive applications. I mean, these things are everywhere, but they're used specifically a lot in automotive, like your struts or your doors or the hood of your car. If your car door makes a creaking sound, it could be one of these that is worn out. Maybe you can't tell by looking at them, but they're just as precision components as roller bearings. I mean, sort of. They've been coined or drawn to size. You want to be careful installing them. I've turned this simple tool on the lathe, just another piece of scrap. That's a loose fit to the ID and gives me a nice square shoulder to push against. I think I can start putting these together. So those two are bushings. I think that goes there. In between the two, I'm going to add some spring washers. I want to put these cup side up so I'm not pushing against the bushing. Oh, hold on, I think I did this one upside down. No, that's still not right. All right, I think that should be right. I just realized I was out of frame. Next up, I've got to make some small bushings I can weld into these countersinks that keeps this whole thing together. Again, snap rings would probably be fine here, but to really screw this project up and bind up the scissor mechanism, nothing has a better shot at doing that than welds. Now, if all went well, these should drop right onto these pins, and once welded, keep the whole thing together. If I can get in here, I'm going to slightly clamp each one of those connections and preload those disc springs just a hair. These may look like washers, and although you probably could use them as very expensive washers, they're really cleverly disguised springs. The disc springs, sometimes called Belleville washers, are little firecrackers and pack quite the wallop. If you've ever read The Hounds of the Bellevilles, you know just how scary. These are 1/2 inch by 60 thou, and they're a bit overkill for what I'm doing, but they're what I've got. They're cup-shaped, by only about a 1/16 of an inch. And if you were to tighten this joint so that you flatten this little bastard out, it'd develop 200 to 300 pounds of force. Doesn't look it, does it? I'm using one in each joint, hopefully, to take up any variation in my parts. I'm under no illusion that my links are all bored parallel or that the connecting pins are perfectly perpendicular to everything in the joint. What I'm trying to avoid is having this thing bind. If these two links, for example, were touching in this position, I'm worried that when this whole scissor mechanism is fully closed or fully open, these links could try to move closer together and bind. Hopefully, this spring could take up some of that variation, if I don't preload it so much that it binds right out of the gate. Clamps are just keeping this snug. I haven't really tightened these down at all, but my welding could be a real wild card here. Hopefully when this weld bead cools, it doesn't pull the joint so tight that I can't move the scissor mechanism anymore. I'm pulse welding these little bushings in place, sort of like a little rosette weld. These don't need to be exceedingly strong, but I don't want them to pop off. At the same time, I want to be careful how much heat I'm pumping into this, because there's still a lined sleeved bearing inside. I don't want to melt its brains out. That feels absolutely delicious. Could have maybe been just a tad bit firmer, a little bit tighter. Although it feels great by hand, I'm a little bit worried that once it's under load, it might start to wobble around a bit. But fingers crossed. For now, it feels really tight. There's no slop anywhere in it that I can get out of it by hand anyway. One thing I did screw up, there was supposed to be another part in here. A part I should have made and captured with these welds. Basically a piece of the drive mechanism, so I'm going to have to figure out another way to do that. But all in all, I think the hard part's finished. All right, it's a new day. My apologies if I sound a bit strange. I'm up pretty early, had a bit of an existential crisis last night and didn't get much sleep. You ever worry that you'll go to sleep, not wake up again, and never know it? Or worse yet, you do wake up only to realize the simulation you're living in, despite the million other things you've got going on. Found it fitting to continue with the This Old Tony shoulder pain subroutine. So last we spoke, we got the scissory bit done. Let me walk you through some of what's going on in my head. One side of this, one set of these links will be stationary, and the others need to slide. In order to do that, I plan to use some C-channel for tracks. That's how you end up with just one thumb. Plan to use some C-channel for tracks. I'll pin the stationary links in the back, creating another hinge here, and I plan to actuate this with a screw. Turning this screw at the bottom would spread the links or pull them together, raising or lowering the scissor lift, which means I need a nut in here tied to these links that can slide in these C-channels, and the threaded rod captive in the frame. Already made, I guess what would be called the cross nut, or what I'm calling the cross nut. Piece of 1-inch cold rolled steel, a nut welded on center, and in this case, it's drilled and has the same sleeve bearings in each end. They're the same size, just a little bit longer than the ones I used in the links. Again, just like the other ones, just maybe 5 or 6 times longer. What I intended to do was have a turned shoulder here, a pin built into this cross nut. That would have just been captured in this link before the welding was done. This is actually backwards. So with the screw captured on one side, as I turn it, it would either push or pull. It's just like one of those car jacks. So I think what makes sense to do next Before I get any further, I should stop, take a moment, and You guessed it, the slidey bits are up next. These are plastic, UHMW I think. There'll be 4 of them, and they need to fit inside these rails. They currently do not. The problem with hot rolled steel is that almost nothing is straight on it. The sides splay out, the walls have taper, and inside corners are rounded. Going into this, I thought I'd mill these out, cut the insides of the rails square, but now I'm considering machining the plastic to match them instead. This is a tapered end mill. These are used for cutting tapers. I think for adding draft angles to mold tools, stuff like that. I don't have too many of these. This is 5 degree. The best I could measure on that hot rolled section is 7 degrees, so it's as close as I've got. And that's a radius cutter. I'm gonna need that to go faster. I like how this is coming together, but full disclosure, it's turning out a little bit backwards. I guess that's what I get flying by the seat of my pants. And boy, are my arms tired. I'll get into some of the details later when it's all put together. We have some viewers still watching these videos two-dimensionally, and it's too early to be frying their brains. For now, let's keep on keeping on. So I had to mill some clearance slots for the center hinge. It's on both sides. I'll have to do that to the top too. As that knuckle swings through, it was running into the rail. Now I need to make the header bar and the lead screw. I might make the top frame while I'm at it. That'll be identical to the rails you just saw on the bottom. And then I can weld this out and try it. Things are starting to get exciting. I'm close to testing this out for the first time, but first let me get you caught up. I welded the big header bar on the frame on the 2 side rails. I used up a full week's supply of Careful doing just that. Seems to have turned out well. Very little, if any, distortion, that is. There is a stretcher across the back. It's only just tacked in place for now. I want to try this out. Make sure it doesn't bind up on me before I commit. The road to failed projects is paved with good design decisions. There are 2 bearings in this, one at the front, directly in the bar stock, and one directly opposite at the back, in just this little makeshift bearing retainer. This bearing in the back doesn't really do anything other than keep the screw from whipping around. In fact, I'm not even sure why I went to the trouble of putting a bearing in here. And here's the screw. Nothing fancy, it was just some threaded rod, Acme thread. I welded a cylindrical head on it. Basically just turned a tight-fitting bushing and welded it on the end. And at the mill, I cut a 3/4 inch hex to use as a drive. I also cross-pinned it for a good measure. The other end just has a small shoulder turned on it. That's to fit the bearing in the back side. And on the inside goes a small jam nut. 2 grub screws just to keep it locked in place. And just for kicks, 2 more disc springs. I'm going to have these face away from each other. So one pushes on the inner race of the bearing, and the other one gives the lock nut something solid to snug up against. The threaded rod is now clamped to that bearing and captive in this front bar. So this is free to rotate, but it can't translate. It can't move. In theory, the only thing that can move is the scissor mechanism. Drum roll, please. As far as satisfying mechanism goes, this has got to be up there with like clicky pen. One design issue with this thing, especially using something like an impact driver to move it, a drill would probably be better. But one design issue compared to say like a hydraulic actuated lift, this screw doesn't run out of travel like a jack might. That means if I drive this too hard or too fast, I could in theory bind it up at the extents. Literally like tightening a screw. I assume in the commercial versions of these that use a little bottle jack, that the bottle jack would run out of travel before it could do any damage to the actual mechanism itself. I cut myself. And not on purpose this time. I ran the numbers, and although 5 legs would have held more weight, 4 just looked a little bit better. I kicked them out 15 degrees on the diagonal. I should have went with 20 with a wider base, but I think this should be all right. Also added some pads, just, I don't know, because that's what you do. My apologies if I covered this already, but I may have added the top section while you weren't looking. It is identical to the bottom frame, the 2 C channels with the plastic blocks that slide back and forth. Except in the top, I've also added 2 small pieces of angle iron, welded top and bottom and drilled and tapped. That's what will hold the actual top. Got a piece of MDF that will sit on here, and that's what it bolts down with. And then I've added these 2 large threaded bosses. They'll come through the top and give me a place to actually anchor the bike to. I'm not 100% sure how I'll tie into this just yet. For now, I'll probably just use some of my milling clamps and attach to the skid plate on the bike, but I wanted to have something there in case I need it. And I've added some denture adhesive. I think I can pop this on and we can give it a try. I don't know why, but this strikes me as one of those rare instances where it'd be nice to have another adult in the room. I'm going to start off manual. I'm going to take this slow, feel it out, get a sense for the forces involved. Last thing I want right now is to rush in all cavalier with my cordless drill and end up with my bike in low Earth orbit. I don't know if you can feel that, but it's surprisingly light. Heck with it, I'm going in with the drill. It's probably higher than I should push it. For the record, the bike is 27 inches off the ground. That's 69 centimeters for you metric folk. Oh, and I should mention, if you decide to build one of these things, use your head or do the math. I'm picking up a bike that weighs less than 150 pounds. If you've got an 800 or 900 pound Harley, well, your lift stand might look a little different. Or at the very least, I'd recommend using a 20-foot extension on your socket. The skid plate, bash plate, on this bike has a curvature to it, and left to its own devices, it leans forward. I'd prefer the bike to rest on that rear flat, so the center of gravity is more above the scissor mechanism. Let me grab one of my mill clamps and I'll try to tie it down here. I suppose I can leave it forward and scoot the whole bike back. Well, I guess either way would work. Let's see if one of these mill clamps wouldn't do the trick for now. I'll have to think of something a little more clever. By clever, I mean faster. That's on there pretty tight. I could knock the whole thing over before the bike came off of it. I don't know, I think I feel pretty all right working with it this way. Famous last words, you say? Maybe. So it's pretty decent height, more comfortable than before. Can't really work on the bike standing up, but I'm sitting in a chair now and I don't know, feels pretty comfortable. Like everything is right here. Is a scissor jack completely indispensable? No. But you know, maybe clutch work, carburetor, wiring, that sort of stuff. Something where you might be sitting in front of the bike, scratching your head, noodling something over. It seems a lot better than having to do that on the floor. Not to mention I can now finally reach the tires with my stubby gauge, and it's way easier to check if all my chain links have the same tension. Come to think of it, I may leave this permanently attached to the bike. This thing could probably help me get past obstacles I currently can't clear. All in all, I'd say I'm pretty happy with this. Looking forward to using it. Should be a handy addition. But to wrap this up, let's do a little bit of post-game. As designed, currently this screw is in compression. At these loads it probably doesn't matter, but when I started I planned to keep it in tension. Earlier when I mentioned I got a few things backwards, that's what I had in mind. That's what I was talking about. But as I was putting this together, to keep this screw in tension under load, I would have had to put this header bar and the drive on the other side. Having it on the other side, however, doesn't give me access with the driver because of the rear tire. There's no room back there. There's really only room underneath the front tire. So in my haste, I flipped everything around. The drive is where I have more space, but the screw is now in compression. I didn't completely think that through. I could have put the header bar on the other side and kept the drive on this side and solved all of my problems. Plenty of space to drive it and kept the screw in tension. But again, for this weight bike and the size of material I used, it probably doesn't matter. Second, I made it too short. I sized this so I could slip it under the bike while it's on its kickstand, which, now that I have it built, is completely unnecessary. In fact, having to fiddle with sliding it under, picking the bike up, dealing with the kickstand and the driver at the same time is more trouble than it's worth. Had I just made this maybe 2 inches taller, it wouldn't have been that big of a deal to just lift the bike up like you would with a normal stand, slip this under, and then the bike is already on there, doesn't need the kickstand, and it's not going to go anywhere. You've got your hands free to use the driver and pick the bike up. Not to mention I'd get 2 more inches of lift out of it. I'm going to use it like this for now, but I may add some small casters. That'd get some more height back into it, and I'd be able to wheel this around the garage. Only downside is it might be too wobbly with casters underneath. This would be complete overkill, but in the quote-unquote design stage, I did want to put the drive on the side. So instead of having that nut on the front, I would have some kind of a jack shaft coming through perpendicular to the screw, and I could actuate it from either side of the bike. I thought to just do that with a simple bevel gear, but the scissor mechanism means that I don't have a lot of space in the plane of that screw. And without making it too complicated, my only other option was like a worm gear of some kind. Something that could shift the drive mechanism down below the screw and still turn me 90 degrees. That might be a fun overkill exercise, something to do on a rainy day maybe. Academic more than anything else. But it would be really convenient to be able to drive this from the side of the bike instead of underneath that front wheel. Well, that wraps this up, I think. I hope you enjoyed that. Thanks for following along. You know what? I highly recommend you build one of these yourself. Fun project. Doesn't matter if you don't have a motorcycle. I'm sure this thing's got 1,001 uses. Use it to pick up girls. That said, though, I'm probably never going to build another scissor mechanism again in my life. But thanks for watching this one.